All right, today we're going to tackle one of the sneakiest mental traps out there. It's a logical fallacy that fools pretty much everyone, from news reporters to CEOs, and chances are it's fooled you too. We're talking about confusing correlation with causation, and we're about to show you how to spot it a mile away. So let's just dive right in with a puzzle. It's a stone-cold statistical fact. When ice cream sales shoot up, so do shark attacks. The two trends move in perfect sync. So, what's the deal here? Is your scoop of mint chocolate chips sending out some kind of secret signal to sharks? Probably not, but let's figure out what's really going on. So, here's our game plan. We're going to solve that shark mystery, break down the huge difference between correlation and causation, look at 3 common traps our brains just love to fall into, see why getting this wrong can be a really big deal, and then we'll give you a super practical toolkit so you can spot the difference yourself. Okay, to even begin to crack puzzles like the shark mystery, we have to get our definitions straight. What is the real story when we talk about correlation versus causation? It's actually way simpler than it sounds. Correlation just means 2 things are linked. They move together in a pattern, like our ice cream sales and shark attacks. But causation? Whoa, that is a much bigger claim. That means one thing directly makes the other thing happen. And this is the most important thing to remember. Just because 2 things are correlated, it absolutely does not mean one causes the other. In fact, this mistake is so common and so ancient that it has its own fancy Latin name, cum hoc ergo propter hoc. It literally translates to, with this, therefore because of this, and it's the official name for this exact logical trap. And that brings us right back to our sharks. So the mystery? It's not solved by the ice cream. The real culprit was a third factor hiding in plain sight: hot weather. Think about it. When it's hot, of course more people buy ice cream. And when it's hot, more people go for a swim in the ocean, which, just increases the odds of a shark encounter. Hot weather causes both things, and that's what creates that totally misleading correlation. That hidden factor is a perfect lead-in to our next part. Our brains are basically hardwired to find patterns, which means we fall for these causation traps all the time. So let's break down the 3 most common ways we get totally fooled. First up, we've got trap number 1, reverse causality. This is a tricky one. It's when we see a clear connection between A and B, and we just assume A causes B, when in reality, we've got it completely backward. B is actually causing A. Okay, here's a classic example you've probably heard a version of. A study finds that children who watch a lot of television also tend to be the most violent. The easy headline-grabbing conclusion? Well, clearly TV is making kids more violent. But hang on a second. What if we've got that completely backwards? Could it be that children who are already more aggressive for other reasons just happen to be drawn to watching more TV? If that's the case, the violent behavior is causing the TV habit, not the other way around. See? That's reverse causality in action. All right, trap number 2 should sound pretty familiar because we've already seen it. It's the hidden cause, sometimes called a lurking or confounding variable. This is our ice cream and sharks problem, where some third factor C is secretly pulling the strings and causing both A and B to happen. You are going to love this example. So get this. A study finds a very strong correlation between people who sleep with their shoes on and people who wake up with a headache. The data is clear. So, does that mean your sneakers are causing migraines? Of course not, right? The faulty assumption is that shoes somehow lead to headaches. The real hidden factor here is going to bed drunk. Going to bed drunk can cause you to pass out with your shoes on, and it can cause you to wake up with a nasty headache. 1 cause, 2 effects. And that brings us to our final trap, number 3. And honestly, sometimes this is the hardest one for our brains to accept. Sometimes a correlation is just nothing. It's a complete and total coincidence. Pure, random chance. I mean, with all the data in the world, some things are just bound to line up perfectly without any real connection at all. Oh man, history is just littered with these amazing, spurious correlations. For over 60 years, from 1936 to 2000, the outcome of a single football game correctly predicted the U.S. presidential election. There's also this bizarre pattern of bald and, well, not bald Russian leaders that alternated for almost 2 centuries. And my favorite? Data that perfectly correlates the number of people who drowned by falling into a pool with nuclear energy production. None of these are real. They're just statistical flukes. Now, as much fun as it is to talk about bald leaders in football games, getting this wrong in the real world, well, it can have huge, sometimes even disastrous consequences. So let's look at a really high-stakes example. Let's take a look at a real-world case study from Microsoft. Their data team noticed a really clear correlation. People who used the advanced features in Microsoft Office were way less likely to cancel their subscriptions. So, the obvious conclusion, right? These special features must be what's making people so loyal. But that conclusion was dead wrong. It was a classic case of something called selection bias. The people who were digging around and using advanced features were already Microsoft's biggest fans. They're heavy users. They were going to stick around no matter what. Imagine if Microsoft had invested millions of dollars promoting those niche features to casual users based on that false assumption. It would have been an incredibly expensive mistake. So how do we keep ourselves from falling into these traps? Well, let's build your very own critical thinking toolkit. It's just 4 simple steps you can use anytime you hear a claim about one thing causing another.
Okay, whenever you see a headline or a study that says A causes B, just run through this quick mental checklist. Step 1, question the link, like, does it even make common sense? Step 2, hunt for that hidden variable, just like the hot weather. Step 3, flip it around. Could the causality be reversed? And finally, step 4, demand better evidence. Look for things like controlled experiments, which are the gold standard.
You know, the Royal Statistical Society puts it perfectly. Being a smart consumer of data and statistics just means keeping up a healthy sense of skepticism. You should always be asking, who's sharing this data, what might their agenda be, and most importantly, what part of the story am I not seeing? So here's the big takeaway. Correlation is not useless. Not at all. In fact, it's incredibly valuable. It's not the final answer, but it's like a giant flashing arrow pointing you in an interesting direction. A strong correlation is a clue. It's a hint that tells you it's time to start digging deeper and asking much smarter questions. So the next time you see a headline that links, I don't know, drinking coffee to living longer or playing video games to having a better job, what's the first question you're going to ask yourself? What's the first hidden cause you're going to go looking for? Thanks for tuning in.